Freedom. It's what automobiles gave us when they changed our mobility. But we're in a revolution. Vehicles are getting smarter, safer, and more complex than ever before. The way we move will forever be drastically changed yet again. I'm here in Toulouse, France, to talk to a company who is leading the charge on something that is faster than any race car. Let me clarify that. I wasn't talking about the vehicles being fast. I'm talking about the breakthrough technology that is powering them.
So EasyMile is a technology company, driverless technology to be exact. So that means that we are putting the brains on a vehicle to make it driverless.
There is an autonomy scale, right? 1 to 5.
Yep.
Where do you guys kind of sit on that scale?
So levels 1, 2, and 3 is when there's some level of human presence inside the vehicle. And level 4 is where it starts to get really interesting. So in the industry, we call that fully driverless or no operator. So it means completely removing any human from inside the vehicle. So the vehicle really does know how to behave and anticipate situations and run its route completely on its own.
For those who might not know, let's quickly break down those levels of autonomy. Levels 1 through 3 require human intervention for assisted driving tasks, such as automatic braking and steering assist. At levels 4 and 5, the vehicle relies entirely on sensory input to handle all driving tasks and make decisions independent of human input. A variety of sensor types like camera, radar, and LiDAR are used at each level to improve vehicle perception for overall safety. Simulation is critical to the design, verification, and validation of these sensors. The higher the level of autonomy, the greater the need for simulation.
But what we're seeing now is that more and more of our use cases and where the vehicles are being deployed are at level 4.
No humans.
No human inside the vehicle
Okay.
at all. There is still a human in the loop, so that vehicle will be being supervised remotely. One that we do is an autonomous tow tractor. So it's like a little tug type vehicle that you might see at an airport towing the trailers of luggage from the aircraft to airside. And the other one that we autonomize is a passenger shuttle. So it's a sturdy passenger bus that will drive up and down autonomously, obviously, closing what we call first and last mile gaps. That might be providing a service on a campus, a medical site, a business park, or it might be connecting, that last stretch between the train station to the bus stop or the parking lot to the entrance of a building, and obviously doing that without a driver on board, completely autonomously.
That is very cool.
Yeah.
This is fascinating, but I've got to experience this firsthand. I love to drive myself, but this is a game changer for everyone. I mean, I'm still amazed that we're on this bus and no one's driving it. It's incredible.
Yeah, I know. There is no driver here, only for some situation a remote operator. We have a very complex computer that replaces the brain,
Right.
and communicate to what we call the low-level architecture in order to manage the steering, the traction, the braking, and so on.
I mean, that's way beyond what I know, but that's what your job is here for, and it's brilliant. It's very exciting.
Thank you.
I think one of the main things that would be on everyone's mind is, what if the vehicle gets hacked? Like, that's a big problem, right? So it's your job to make sure that doesn't happen. How do you work with Ansys to ensure the safety of the vehicle?
Yeah, so here we are talking about very complex systems made by a system architect at EasyMile. And based on that, our mission is to analyze all the potential scenarios, so the failure, which is the safety engineering, and all the potential malicious attack. You have to know also that all the safety and cybersecurity demonstration for a complex system is very, very complex. So it's heavy demonstration, and for that we need tools. We need complex tools to do that. So it's the main reason we use this Ansys solution.
That's great.
And at the end, to prove that it works well to our customer, to the authorities, regulation authorities, but also to independent assessor, in order to get a stamp at the end saying all the
approved.
Approved, and all the known attacks are well managed.
All good, yeah. With EasyMile using simulation to make the brains of autonomous vehicles, let's investigate the sensors that give the brain its information about the world it's operating in. Next stop, Tel Aviv, Israel.
And what we do in Innoviz is developing LiDAR and perception software for self-driving cars and for robotics in general.
LiDAR may seem like black magic, but it is very real. LiDAR stands for light detection and ranging, and it is a type of sensor that uses pulsing invisible laser beams to scan an environment and produce an accurate 3D map. In autonomous vehicles, LiDAR scans its surroundings in real time, enabling cars to avoid collisions. It can see at long distances and through poor environmental conditions, like nighttime or rain and fog. Simulation is used in the creation of all aspects of LiDAR sensors and systems to predict how they will perform in the real world.
Sensors today need to be small, need to be reliable, and need to be, of course, low cost enough so we as consumers can afford them in our cars. And more than 90% of the accidents are caused by human error. This can be prevented if we really let the car drive itself. And the sensor to enable that is LiDAR, because LiDAR can provide a very high definition 3D image of anything that happens around the car. And this is what the car's computer needs in order to be able to understand everything around it and in front of it with the accuracy that's needed for real, safe, autonomous driving. So developing the LiDAR was and still is super challenging because we need to take so many different conditions and requirements into consideration. And this is where simulation comes in critical.
We do the design, analysis, prototyping, and validation. Again, everything in-house. And this is why we need the Ansys software. We use both FEA simulations and CFD simulations for structural, thermal, and CFD in order to simulate our designs.
Safety systems have become better. So if in the past this was mostly about passive safety, like airbags, today this is more about active safety, about the car's ability to prevent an accident in the first place. Delivering things to the world that keep people safe. This is really my passion.
Join us next time on Driven by Simulation as we go back to the iconic car company where it all started for me.